Welcome back. This is another exciting episode of Mr. Takeda Teaches Algebra. I'm your host and teacher, Mr. Takeda, and I'm going to teach you some algebra right now. This is lesson 2.4, Solving Multi-Step Inequalities, wherein we ask the essential question, how can you solve a multi-step inequality? And I will answer that quite simply, the same way you solve equations. We're going to simplify things first if we need to. We're going to use in this case, property of inequalities, not equalities. Those properties that where you do one thing to one side, you do to the other, and we've already seen those in the single steps. So let's go ahead. So these first two examples we can see are two-step inequalities. I have division and addition, and here I have multiplication and subtraction. The only thing we have to really watch out for is that idea of multiplying or dividing both sides by a negative number, which we saw in the last lesson. Okay, so first thing, I'm going to subtract 7 from both sides here. And that leaves me y divided by negative 6 is less than 7 minus 7 is 0. And then 9 minus 7 is 2. And then I'm going to multiply both sides by negative 6. And negative 6 divided by negative 6, of course, is 1, so 1y. I'm going to reverse my inequality symbol around because I multiplied by a negative number, and then negative 12. So y is greater than negative 12. So let's say 0, 2, 4, 6, 8, 10, 12. Oh, wrong way, negative 12. I'm sorry. 0, negative 2, 4, 6, 8, 10, negative 12 we'll call right here. I want an open circle because I'm not equal to negative 12. And then the numbers that are greater than negative 12 are to the right of negative 12. Example B, two steps again. First, I have to add 4 to both sides. That leaves me 2v greater than or is greater than or equal to 12. And then dividing both sides by a positive 2, I'll get left with v on the left greater than or equal to 6. Now, in this case, of course, I do not reverse the inequality symbol around because I am dividing by a positive number. Okay, so v is greater than 6. So let's see, 0, 1, 2, 3, 4, 5, 6. And we'll put 9 there for giggles. My boundary is 6, and it's equal to 6, so I'm going to color that in as a solid dot. And I want the numbers that are greater than 6, so I'm going to go to the right. Okay. Good. Basic examples, two-step inequalities. This example has variables on both sides. And both sides. And we'll use the same thing that we did in the equations. We want to get the variable terms on one side and the constants on the other, and then simplify after that. Okay, so both sides are already simplified in terms of I can't add like terms on either side. So I'm ready to move my variable terms. I'm going to subtract 2x out of this side. And if I do that, I must also do it to this side. So 2x minus 2x. That's going to leave me 4x minus 5 on the left is less than 11. And then I'm going to add 5 to both sides. Remember, I'm still trying to isolate that x variable. So that leaves me 4x is less than 11 plus 5, 16. Dividing both sides by, and this is a positive 4. So I'm not reversing any inequality symbols around. We'll have x is less than 4. Okay, so any numbers less than 4 will make this inequality true. Variables on both sides, again, very similar to equations. Last couple examples here involve simplifying using the distributive property. So we can see on the right side here, I have to distribute the 4. I could technically divide both sides by 4, but then we end up with this fraction over here. So I'm going to go ahead and distribute. So 4 times 2b is 8b, and 4 times 3 is 12. And I can see right here I'm going to have this 8b thing happening here. If I subtract 8b from this side and do the same thing to this side, they're going to cancel out on both sides, giving me negative 3 is greater than 12. And this is a false statement. So this one is going to be a no solution, because negative 3 is never greater than 12. And then for B, let's distribute over the left side. 2 times 5w is 10w. And 2 times 1 is 2. And again, here we can see that if I subtract 10w from both sides, they're going to cancel out on both sides, leaving me negative 2 is less than or equal to 7. And this is a true statement. So this is going to be infinitely many solutions. Infinitely many solutions. There we go. Yep. So it doesn't matter what number you choose for w here. It will always be true. This side will always be less than this side. Well, because look, there's going to be a difference of 9. This side's plus 7. This side's minus 2. So this side's always going to be greater. Okay, and so we've covered distributive property and special cases in this case. And again, it's the same with equations. The variables cancel out the same on both sides, and the constants tell us whether or not we have no solution with a false statement or infinitely many solutions with a true statement. And that's it for now. Like I said, easy peasy, lemon squeezy. We'll see you in class. Bye-bye.